It really is wonderful to be here today. And can I begin by acknowledging the Gubbi people on whose lands we are meeting here this afternoon. We honour their elders and their continuing cultural and spiritual connection to this land as we walk together on the path to reconciliation. Obviously, I also want to acknowledge Terri Irwin, Robert Irwin and the Irwin family who are joining us here today. Our very special guest speaker, Professor Craig Franklin from the University of Queensland, as well as the many staff, students, alumni and visitors who are here with us at Australia Zoo today. Now, we're here for the 10th annual Steve Irwin Memorial Lecture, but the University of Queensland's partnership with Australia Zoo extends much further back than that, and in fact to the year 2003. And it was in that year, 18 years ago, that UQ's Professor Craig Franklin first encountered the crocodile hunter, Steve Irwin, while studying freshwater crocodiles along the remote rivers in far north Queensland. And they instantly hit it off. And at that chance meeting was the beginning of a very close and trusting research partnership into crocodile behaviour and movements that continues to today. And it's a partnership that combines our university's scientific and research expertise with the croc capturing skills of the Australia Zoo team. Now, while there's scientific research into crocodile behaviour in itself is immensely valuable, its impact is amplified because of our collaboration with the Irwin family and Australia Zoo. Because of that partnership, we're able to do so much more because we are obviously very keen to educate people around the world about the importance of wildlife conservation and ecosystem protection. And given the pressures, as we all know, of a growing population and a changing climate, this work has never been more important. So at UQ, we're immensely grateful to the Irwin family for their support, and this annual lecture is a really important way in which we honour Steve's memory, but we also acknowledge the ongoing and very important relationship with the Irwin family and with Australia Zoo. And so I'm delighted that the 10th annual Steve Irwin Memorial Lecture will be delivered by Terri and Robert Irwin in partnership with Professor Franklin. Professor Franklin's areas of expertise are zoology, ecology and conservation science, and this crocodile research project that we're going to hear about today is actually the longest such project that's ever been undertaken in the world. So please join me in welcoming, here we are, Craig's coming, Terri's coming, and Robert to get the show on the road. Thank you very much.
G'day.
Thanks very much, Debbie.
Thanks very much, Debbie.
I normally sit on that side of the fence. I'm just kind of pleased that the Crocoseum doesn't have a croc in there.
We can
at
fix
this
that.
present point in time. It was 2007 that we instigated UQ, the Steve Irwin Memorial Lecture, and it was in recognition of Steve's huge contributions to conservation. This is the first time this has been held here at Australia Zoo, and what a fitting place this is, the Crocoseum. A facility that Steve dreamed about, planned for and built, and allows the communication of conservation to be clearly put out there by the Irwins. Steve was a dear friend, a valued colleague, and he was also appointed as an adjunct professor at the University of Queensland, again for his recognition. Here he is, the man himself, next to one of our crocodiles. So the talk today, it's a short talk, and of course it's about crocodiles, but what underpins it is the power of collaboration. been inspired by a man, and then having the imagination or to follow your dreams and to see what results. And I think what you'll hear is a remarkable story where we dared to imagine. I'll hand over to Terri to give you a bit of background.
Awesome. Thank you, Craig.
Thanks, mate.
And I'd like to thank my esteemed colleagues for joining us. I just wanted to use the words esteemed colleagues in a sentence, so I picked the IBIS. Thanks, everybody, for coming today for the Steve Irwin Memorial Lecture. I'm going to keep an eye on the time and tell you a little bit about how it all started. And I think the best way to convey how we started our relationship with the University of Queensland and Professor Craig Franklin is to give you an idea of the philosophy, the ethics, and the passion behind Steve's beliefs for the importance for research. So I got a little video where Steve kind of articulates the importance of protecting wildlife, so I thought I'd start with that.
If there's one thing that I, Steve Irwin, would want to be remembered for, it's be remembered for passion and enthusiasm. Conservation is my job, my whole persona. My life revolves around that. So do my friends, family, colleagues, everyone I know is involved in conservation. And you know, I get this overwhelming feeling that I'm sharing my wildlife encounters with you. What a beautiful thing, and I never really thought that was going to happen. A lot of people say, why? Why did you touch that snake? Why did you catch that goanna? If I can't get animals into people's hearts, there'll be no conservation. There'll be absolutely no love for our wild animals, and that would be devastating. Everything would just suffer, and this would be a very ugly world. We need wilderness areas which are conserved by looking after, let's say, crocodiles to produce food and water and to have a very healthy green planet. And in essence, by conserving wildlife, I am helping humanity. That's what I'd like to be remembered for.
Yay. So with that, I think you can understand why I like to use the term applied research. So research in itself is incredibly important. The discovery of new things, the need to continue to learn about our natural world and environment is incredibly important, and research for itself is critical. Sometimes we research things not really knowing why and finding out later why they're so important. But with Steve, he had this desire to apply the research, to get people to want to conserve and protect wildlife. So when I was pregnant with Robert, which was some 18 years ago now, we embarked on some crocodile research work in the Cape at Lakefield National Park. And at the same time we were up there looking at salties, Professor Franklin was there with UQ looking at freshies. And so we kind of collided and got to talking. And the thing about Steve that wasn't readily noticed because he has such a childlike passion for everything is that he has a very science mind. He's very curious and inquisitive and wanting to learn, and was so excited to meet Professor Franklin because finally he had someone he could ask all these questions to. And Craig would very patiently explain things until Craig started going, I don't know. That's a very good question. And that's when I think their relationship really hit it off, that they realized together they would be able to learn a lot when it came to science and crocodiles. So Queensland has 2 species of crocodilian. We have freshwater crocodiles and saltwater crocodiles. And studying saltwater crocodiles, I think, became a passion for Steve because they are the largest crocodilian, the largest reptile on the planet. And they are utterly fascinating. To this day, I sit down with Craig and it's like climbing the mountain. I say, tell me about their physiology and tell me more about what we've learned from our research. And we couldn't study crocodiles without Craig and the University of Queensland because we are gathering every year literally millions of dot points of data to be able to study and learn about these incredible animals. And Craig is one of the most knowledgeable, talented scientists that I know, but presumably without our help, would not be able to catch as many crocodiles. So what we can do is come along and read the river, and with a great deal of love and respect and consideration towards these beautiful animals, we can capture them and attach satellite trackers and acoustic tags and study this very cryptic predator. And it's so important because Craig explained to me that crocodiles are apex predators, which is like the roof on your house. If you take the roof off, everything underneath suffers. If we lose apex predators, everything in the ecosystem will suffer. So this was the beginning of Steve's relationship with Craig and the university and a long-term relationship of formally studying crocodiles. So when we would get together to publish a scientific paper on something new we learned about crocodiles, I would explain to Craig that we also needed to showcase this with the Today Show or 60 Minutes because that's getting the information out to the general public. Now, there's a lot of tricky university people here, but usually when I ask this question, not a lot of hands go up. So when's the last time you read a scientific paper? Okay, you're all university people, so. But for most of us, we're getting our science kind of through mainstream media. So I want to make sure the story of science is told in a way that we can all embrace it, learn from it, and become passionate about doing our part to protect the world. And Steve did that so well through the Crocodile Hunter series. And we're very proud to be continuing his legacy and continuing to carry on his mission and his message of conservation. So I'm really excited because as a mom, I ended up with a very science-minded daughter, Bindi, who participates in the crocodile research work every year. And Robert, who is very much into photography and just loves the science of catching crocodiles. And we need to catch them so they're safe, healthy, unharmed, unstressed, and in perfect condition when they're released again. So I'd love it, Robert, if you would explain the intricacies so everyone here can go home and catch one for themselves. How do you catch a crocodile? Thank you.
Thanks very much, Mum. Thank you.
No worries.
Good on ya. Well, g'day, everyone. As Mum said, I have the great honour now that I'm going to be 18 in a couple of weeks, which is exciting. Bit crazy, isn't it? Yeah. So I've had the good fortune since I was literally 8 months old on my very first croc research trip to experience this firsthand. And I've got to tell you, it's the most action-packed, exciting, fascinating, amazing thing one could ever be part of. And I feel such an honour that I've got to be part of it for so long. Of course, you know, a massive thanks to the University of Queensland, to Craig Franklin for being here since day one and making sure this science continues. And of course, my amazing mum, continuing Dad's legacy. You inspire me every day. So thank you very much. And it's a family affair. It really does feel like a family every time we get to go up onto the reserve and catch crocs. So of course we head up to the Steve Irwin Wildlife Reserve every year. It's a beautiful 330,000 acre property that we have protected up in Northern Australia. I'll start my little timer here because I could talk the legs off a chair about this. So of course, The reason why we do this, the reason why we're all here, the reason why this is the Steve Irwin Memorial Lecture is because we are continuing Dad's legacy. Dad was the absolute master. He was an incredible science-minded person, but he was also incredible at catching crocodiles. I mean, that's no secret to everyone. He brought crocs to the world through documentaries, but he also created a method to catch crocs that had never been seen before or since. To this day, we are the only ones that employ this tactic to catch crocs. It's the most successful, and most importantly, it is completely 100% non-invasive to the croc. Every single croc we have ever caught is released back to the river 100% or a little better off than when we got them. Often, crocs have some pretty crazy injuries, and we do our best to give them a little helping hand before we let them go again. But we'll head over the next slide and we'll show you a little bit about what we do when we get there. I suppose for me, I've gotten to step into more of a leadership role when it comes to the crocodile capture. But catching a croc in the wild, it is no easy feat. The first thing that we do, we get onto the river, the beautiful Wenlock River, one of the most remote, untouched areas left on the planet. There we are driving the boats, the whole croc team head out and we look for signs of crocodiles. And in this next slide, we see some of these signs that we're looking for. As you go along the river system, you might see this little slide there, a little hole in the ground, doesn't look like much, but to us, this is evidence. This is where a croc's been. That's about a 10-foot, probably male that's just pulled into the water there. That's about 20 minutes, maybe half hour old, and you can see that nice big footprint. Those two claws that drag down. These are the sort of little details that we look at as we go all the way down the river. We trap along quite a large stretch of river. We take all of the equipment with us and we take all of it out again. So what we do is completely harmless to the environment. We leave no footprint. But once we've scouted the river, we know where the densest populations of crocodiles are. We hopefully get a good idea of numbers. Then we start to actually head out and set traps. Now in this next slide here, you're going to look at us starting to actually set these traps up. It takes the better part of a week to set about 20 traps all the way along a 60-kilometre stretch of the Wenlock River. It is hard, hot work, let me tell you. And we've got a team of 30 people. It takes every ounce of our effort to set up these traps. But the most amazing thing, we talk about it every single time we're up on the reserve and we set croc traps. Dad used to do this on his own with no help. He would set traps, catch crocs for 6 months out of the year completely by himself. And these days, it takes about 20 people and a week's worth of work. He was an absolute machine. Now, there's a few different kinds of traps that we use. Once we've gone in, we've set everything up, this is what a finished trap looks like on this next slide. That is the goal. Something that really works in, meshes in with its environment so that a crocodile swimming past won't suspect a thing. Now, we've got a few different types of traps that we use to catch crocs, all of which are designed so that that croc has plenty of space, plenty of shade. When we're setting a trap, not only do we want it to be in a spot we know crocs are frequenting, we're also looking at tide marks. We're also measuring moon cycles. We're seeing when the high tide's going to hit, making sure there's enough shade so that they're comfortable. There's a lot of different things that we look for. Now, that there is a gate trap. On this next slide, you'll see two of the other traps that we use, a floating trap and a bag trap. On the right there is the floating trap out of the water, but when it is submerged, you'll see floats on the side. Funny that, being a floating trap, figures. And it'll sit half in the water and half out of the water. So a crocodile can swim in, grab a chunk of bait sitting at the back of the trap. That pulls a cord, which pulls a pin that gate is sitting on. Bait's pulled, cord's pulled, pin comes out, gate drops. You've got him. On that side, on the left, that is the bag trap. And that, to this day, is the most successful trap design that we have. Still works so well. And that is the trap that Dad first designed. It is extremely, extremely complicated and can take upwards of 4 or 5 hours to actually set up. It's a large trawler mesh bag, basically like a giant sock that's about 15 foot long. The mouth on the front, there's a rope that goes around the mouth of that netting, stands about this tall, probably goes about to where the line of the shade is. We set up sticks. We basically have to support it so it can stand freestanding. then there's an intricate array of ropes. Basically a mouth rope that threads around, as you can see, the front of that netting. That is attached up in the top of the highest tree, a pair of weight bags. Then, at the back of the trap, there's a piece of bait. That piece of bait is tied to a trigger mechanism at a tree behind the trap. That trigger mechanism has a rope that is then attached to the weight bags. Therefore, a crocodile walks in the trap, pulls on the bait, the cord is pulled, the trigger mechanism fires, a pin comes out, releasing the bags, which closes up the front of the bag. Very, very complicated. I have no idea how Dad came up with it, but it is incredibly successful, and all you need to know is it catches a bloody lot of crocs. In the next slide, you'll see how it works. This is a trap going off. We have to test it. Every time we set a trap, we need to test it before that crocodile is caught, and that shows you what happens. It's basically, a nice big mesh bag, pulls itself up, the crocodile can sit in there, and the croc can struggle all he wants, but that nice soft mesh keeps him comfortable. Now, I think we've got one more slide here to show you. This gives you an idea of the difficulty that we face catching crocs. This is no easy feat. This crocodile here spent the better part of the month while we were up on the reserve. Most nights, we had a camera trap set out there. He would come into the trap. He'd sit right inside the trap, looking at the bait night after night after night after night, never set it off, not once. He just wasn't feeling it. Crocs are intelligent animals, very, very smart. There's a reason they've been here for so long. It's because they never do the same thing twice, and they know this area. They know this river like the back of their cute little webbed feet. And so he knows something's up. He's not going to set a trap off. Very, very hard to catch a crocodile. You'd think they'd just see a nice big juicy piece of meat and set it off straight away. A lot of times it can take, sometimes, year after year to catch an individual. My dad used to do a lot of crocodile relocation. Sometimes there'd be a big problem crocodile. Acco, in fact, the biggest croc that we have just behind you guys in the triple ponds, took him 2 years to catch this individual because he was so smart. He was unfortunately under threat of being shot. But anyway, that gives you a little bit of an idea about how we catch these crocs. I've only got a few minutes left, but once we've set the traps up, once we've actually caught a croc, then comes the exciting part. In order for Craig and the team to be able to attach satellite trackers, acoustic trackers, do all the amazing things that Craig's going to get into, you've got to have a crocodile to work on. And the reality is, catching an animal that's 15 foot long, about 200 times stronger than any human being, that is very, very difficult. And it's thanks to the systems that Dad put in place that we're able to do this. In fact, every single thing that we do with crocodiles, everything is exactly how he did it. We haven't changed one single process. The way it works is we come up to a trap site. The first things first is to assess the condition. We want to make sure that the croc is under no stress. If there's sunlight, if there's anything like that, we always process a sunnier trap site first. After we've done our checks in the morning, we see where the crocs are located. We'll do the one that's in the sun, the one that possibly could overheat. That's the one that's done first. We'll get up to this trap, we'll open it up, we have a big briefing with the whole team, and then basically we use what's called top jaw ropes. We get a nice long piece of soft bamboo, a rope on the end of it. We basically lasso a rope over the top jaw of the crocodile. The croc is then pulled out of the trap. Now, meanwhile, everyone in the team is assigned to a certain role. People on the front of the ropes pull him out, and automatically he's going to start to death roll. This is a sign of dominance. This is a tactic you've probably seen right in there in the Crocoseum for a crocodile to use if they are grumpy. And a lot of the crocs we catch are very, very grumpy with us. So they'll do death rolls, and what we actually do is we have one person goes to the side, the team leader, with a rope. As that croc rolls, its jaws get bound up with the rope. And then that makes it a lot safer for the jump team. Once the crocodile has its jaws as safe as possible, then the jump team comes in. We've got everyone assigned basically like a stack of dominoes. Imagine the croc sitting here. We all line up, we get ready, it's the most tense time, and as soon as the leader, the person who's leading the jump team says go, it's just boom, 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 boom. Everyone on, nose to tail, and basically we can secure the croc instantly. We cannot sedate crocs. If we were to do what we do with a polar bear and just go, blow dart them and have them drop over and do everything we need to do and then wake them up again, they have a very, very slow metabolism, so it just wouldn't work. You'd risk the croc's health. In doing this, we're nice, soft, squishy. We keep them held and secure, but there's not a mark on them. and they don't mind at all. It's pretty hard to hurt a dinosaur's feelings. Now, I've only got a couple minutes. I've already talked way too long than I should have, but here's a little video just quickly to explain and show you one of the most interesting crocs. This is Ryan, the largest crocodile that we're currently tracking. It was a heck of a time for the team, but a very, very exciting one and a little bit of fun. Check it out, guys.
What happened there? What's going on there?
It looked like the tail that traps down. Do you want to go in this schmutz here?
No. Go around that way.
Do you reckon it's caught halfway in?
I don't know. I don't know what the going on there, but it's a big crocodile. I don't care if you're on the permit or not. Everyone else. Go. He'll get through there. He'll get through there. You can see the water through that gap. Go right.
Mate, whole tons of you.
Mate.
Holy moly.
Dude, shower!
Well done, mate.
So that gives you an idea of some of the action. Yeah, it's exciting, isn't it? Yeah, no. Makes you want to go catch a croc, doesn't it? So that gives you an idea of how this all works. It looks like an absolute rodeo. It's not. It's a very precise science catching a crocodile. We've never had a single incident, human or croc. We take great pride in that, and it is an honour for me and for the whole team to continue Dad's legacy catching these crocs. But, of course, the reason why we do this is to protect crocs through incredible croc science, and that's thanks to Craig. Over to you, mate. Thanks very much, guys.
Okay, thanks, Robert.
Good on you.
Thank you. I'm now wondering whether I'll get called to the Vice-Chancellor's office on Monday to talk about workplace health and safety. But I can tell you we haven't had an injury, and we have caught over 500 crocodiles. An outstanding kind of safety record, and it comes down to a team effort, understanding everybody's capabilities and their expertise. And that was what Steve was so good about, was being able to look at people, understand what they're capable of, and then working out how you fit into the team. So what this enables us to do is the science. And our science is around tracking crocodiles. And when we first met up, Steve and I met up, it was all about trying to track crocodiles in the wild and using technology to assist us. I mean, you just can't stand there in the river and track crocodiles. They spend most of their time underwater. And so we use, in this case here, satellite technology. There's a transmitter on the back of the crocodile. It transmits to a satellite that orbits the Earth, and then that information gets transmitted to my computer. So I can sit at the University of Queensland in my office and find out where the crocodile is. And so what we get to see are data like this. Each of those dots, this is a single animal, each of those dots is a position fix along the river. This is just a month's worth of data, and we can start to build up information about where the crocodile lives and how far it moves. What we can also do is use different types of technology to look at movement on a fine scale and underwater. And this is a device that has a three-dimensional accelerometer, and what that means is it can determine how the crocodile moves through space over time. And from that, you get a really smart PhD student who can animate the data. And this is Caitlin Barham's work. And although difficult to see here, you can actually follow the crocodile underwater and see how long the crocodile dives for. So Terri, how long does a crocodile dive for?
Longer than you might think, Craig. And wasn't there an accelerometer in Back to the Future?
That was a flux capacitor.
Oh, thank you.
Similar, though. Similar technology.
We have actually discovered that crocodiles can hold their breath in excess of 7 hours. Maybe 10,
7
but
hours.
definitely more than 7.
Long time.
So we have the Olympics coming up in 2032. These are the Olympic champions in terms of breath hold ability. No animal that just breathes air can stay underwater for so long. So what can we do? Well, we had to move our location. And in 2008, we shifted our operation from Lakefield National Park to the Steve Irwin Wildlife Reserve. Now, this is near the tip of Cape York Peninsula. As Robert mentioned, I'll mention it in hectares, it's 135,000 hectares. And its southern border is the Wenlock River. Now, the reserve is a remarkable place to be based at. It's where we run our crocodile research program. Currently, we have a few problems. We have a road that is going through it, and we have the endangered palm cockatoo. And as a conservation biologist, I'm concerned that the damage that may come from the building of this road right through our reserve. So the Wenlock is where we do our research. And these days, we're still using satellite technology. And we're starting to build up a picture of how the animals use the space through time. Here, each colour is a different crocodile. And you can see how they're moving up and down the river system. Some animals can move 60 kilometres in a day, can move over 1,000 kilometres in a couple of months. They can roam vast distances. They can go out along the coastline into new river systems, and they've got this remarkable ability to come back. We also have animals that stay put year after year after year, and Drew is one of our boss crocs, and he holds a territory. And you can see his territory here, but also the territories of the other males. Each of them has a piece of real estate on the river. They're big animals, they're wanting to attract the females, their mates, and we can actually start to divide the river up and see how that is segmented up. And the challenge for Robert is to fill the spaces in. So where the gaps are is what I challenge Robert to, is to find those crocs and catch them. So what else are we doing? Well, we're using new technology. These are solar-powered satellite transmitters. The problem with the traditional ones is the battery runs out after about a year. But here, we're using the sun to keep the batteries recharged. We can get more fixes and attach them, and they can give us data for many, many years. And this device is actually designed by a UQ graduate who now has won an engineering award for animal tracking devices. And with those high density of data, we can start to build up heat maps. And those red dots show the areas in the river where they spend most of their time. And then what Robert also mentioned was another type of tracking technology that we use, which is acoustic technology. This is data that is transmitted underwater, not via satellite, but underwater to listening stations. And these are very carefully implanted, and this is where Bindi comes in. Bindi has been assisting me with the surgery since 2007. And we anaesthetize the area, make a small incision, and then pop it under the skin. Suture it back up, it heals, and that device stays with the crocodile. But what's great about these devices is that they're energy efficient, they last for about 10 years, and they record not only the position, but the body temperature of the crocodile. And here, showing a couple of crocodiles, just a small amount of data, showing how the temperature changes from year to year across the seasons. Of course, hotter in the summer, cooler in the winter. And what we can see here is that the body temperature of the crocodile aligns with the water temperature. We call them ectotherms. Often they're known as cold-blooded. But what that means is that the environmental temperature dictates the body temperature of crocodiles. Here we can see seasonal changes. What we are interested in is what is climate warming doing. I think we all have seen the disappointment that has come out of Glasgow. These crocodiles will provide us a view into the future, because the tags that we implanted in August this year will still be giving us data in 10 years from now. We've collected over 10 million individual recordings of body temperature, and there is some indication that those body temperatures are increasing. And we know that that could be significant for the health and the well-being of crocodiles. So just to end off, I said this was a story about collaboration, the power of harnessing a partnership that is long-term. In the face of climate change, we need long-term data. When we look across at all the crocodilians around the world, there's 26 species, just under half of them are heading towards extinction. The work we're doing, we hope, will protect them, will save those. But we have this looming problem of climate change. So we are running the world's largest and longest running tracking program on crocodiles. I said that at the beginning, that when you start off, you dare to imagine what might be possible. I couldn't be prouder of what we've achieved. I think Robert, your dad, would be extremely proud of where you are now.
Thank you.
You're leading the capture of crocodiles, and Terri, what you've achieved and the support that you've provided that will inform researchers around the world, and then to share those discoveries via their huge network makes my job extremely worthwhile and pleasurable. I'd like to thank you for your attention. I'm welcome any questions. I'll just stand up the front down here. And with that, I think we'll call this to a close.
Yay.
Thanks very much.
Okay,
guys.
thanks very much.
Craig.
Thanks, everybody.
Thank you.
And thanks, too, to everyone's support, because everybody here, by coming to Australia Zoo, by having a snack or shopping in the gift shop, funds go back to conservation work just like this research. So thanks to you, we're going to be able to keep this research work going on. So we really appreciate you, too. Thank you.
Thanks very much.
Thanks, guys. Bye.